you are losing a lot of value if you can't make it. There's an enormous return on investment for any company that's paying a developer a reasonable developer wage and sends their developers here. I can't tell you how big of a mistake it is not to send someone to CppCon.
Welcome everyone on my talk about the physical units library. Today I'm going to talk about my life's work and legacy for generations that will live after me for years, hopefully. I've been doing this for 7 years now, I think. And probably I have still a long way ahead of me, at least, if it's going to be standardized, because right now we target cplusplus 29, which may seem like a far go, but actually there's not much time for us. So we are in a tight schedule in order to deliver this in cplusplus 29. My name is Mateusz Pusz. I'm the principal software engineer at EPAM Systems, but also I am independent trainer and a consultant. I delivered training here during the weekend. Some of my students are in the audience here right now. And I encourage you to also take my trainings next year in CppCon. We have just had a breakfast of instructors and we discussed what will be the strategy for the next year's trainings as well. So they will be here. I hopefully will be here as well. So I encourage you to register to trainings, not only mine, but also my friends as well. Because it is a really good quality thing that you can attend and learn a lot during these 2 days of training. But let's talk about quantities. Not that long time ago, if you've seen a movie with famous actors, they were often placed in the distant future, right? The main hero was getting into the car and the car was driving itself to the destination. It's far so futuristic that typically this movie was placed in something like 2235 years in the future, right? So something like 200 years from now. But actually, it turns out that we have this right now, or we'll have it tomorrow, right? The autonomous car starts to appear on our roads. We tend to trust with our life, or at least our health, on those machines, right? This is why it is so important to realize that our software has much more impact right now on the people's lives and health than ever. It's not only about the autonomous cars that actually drive you to the destination while you sleep or work, but also about, for example, healthcare and other industries as well, right? Imagine what will happen if this robotic machine will move the needle by 1 inch instead of 1 centimeter in the body of a human, right? And those errors tend to happen because units are inherently hard. And I don't mean like programming units, it's just communicating units between people. It's inherently hard. We have plenty of proofs about this in the human history, starting from Columbus that I'm going to talk about, through many other problems, because even like Vasa sank, one of the reasons was actually units. And there were many other mishaps as well, including the, of course, famous mass climate orbiter that probably many of you know. It's not only about the future or now, because actually I started work on this or think about this like 10 years ago. This is me 10 years ago in my glider over high mountains during competition. If you notice here, I have a small computer that actually provides me tactical flight computer information that I'm using to plan my flight during competition. In general, it looks something like this one. I have my position on the map, I have some 3D map printed below me, and a destination. Here, you may not see the issue, but there's also a vertical view that actually shows you what happens. And when I plan if I can go to this destination or not, over this mountain, I want to be sure that I can trust the software, because as you can see, it is quite tight. And well, glider doesn't have an engine, right? So you can only try to land once or go over the mountain once, because if there will be no lifts, you will not be able to go higher. And sometimes this happens, you have to account for this, right? So this is why units, quantities are really important to get right. We talk a lot about C++ safety in recent years. Right? This is a major concern in the community. We talk about safety on many different levels, right? Memory safety, application safety, thread safety, plenty of different safety possible scenarios. But this is a huge thing. We want to deliver safe software to our users. We are here not in the interest only as a developers for us to make it easier for us to type, but also as a user, because besides the fact that you're sitting in front of the computer typing some software, you probably also have a car. And probably in the future, your car will also drive you to your destination. And I don't know how it's for you, but it's for me, as I see code bases as a consultant all over the world, I sometimes am afraid of going into this car and trusting it, because I know how the code is written, right? And we want to improve that, right? We are not only the developers providing this, but also users. And this is important also for us to be safe. In C++, we can talk about improvements in many different levels, right? We can talk about improving fundamental types, for example, to have no undefined behaviors on overflow or whatever. We talk about updating core language rules, like initialization and many other stuff, to be safer. We had plenty of talks and discussions and panels about it during this conference about this. But also we can provide safer high-level abstractions in the libraries. And this is what this talk is about. I'm a trainer. I deliver trainings to people, but training by itself will not solve the solution here, will not solve the issue. It's not a solution as a single thing that we can provide. The problem is that more and more engineers right now are expected to write safety critical software. It's much more than it was like 10 or 20 years ago. Because right now, as I said, plenty of software, plenty of our industry, plenty of our lives daily depends on the computers. And that's why more and more of us have to write this software, but this experience in this domain is hard to come by. I can provide trainings, but things like units are not only hard to code, they're hard to communicate by itself. Right? People make a lot of mistakes communicating units in daily life. Plane has crashed, things get sideways, cars are derailed in the Disneylands or other amusement park because of issues with units. And it's not about programming this in C++, right? Also, code written for physical units and quantities often is not written by C++ experts that can write templates, understand template errors, and possibly fix that. Often, such code is written just by engineers that use C++ just a tool, not as their proficiency for daily life, right? And that's why library like this has to be easy to understand by everyone. The main goal of this library is to generate errors, compile time errors. It's a different maybe scope than for many other stuff, because in many cases people optimize for performance, they optimize for features, for maybe with some fluent style and some domain-specific languages to provide better usability. But the main purpose of this library is to generate errors, compile time errors, and those should be easy to understand. If you're not making errors, you don't need this library, right? If you can write all of the conversion factors by hand and make sure that you are not doing problems with calculations, like calculating speed and doing length by time instead of multiplication, then you don't need this library or another, right? If you're not making mistakes, then just use doubles. But it's hard, and we are doing those mistakes. When I'm talking about this, people typically think, well, it's aerospace, autonomous cars, embedded industries. Those are the obvious, of course, use cases for such a library. However, it is not the only place where this library can be used. I have users in many different domains. I'm sometimes even surprised that my library can be used in specific domains. This is what I have so far, and probably there's even more, right? We have maritime industry, we have military, astronomy, 3D design, robotics. We also had a great talk 2 years ago, I think, or a year ago, about audio, usage of this in audio, where actually there's no physics. There is just beats, samples, and bit rates, right? Medical devices, of course, all of the universities, scientific institutions, even finance, including high-frequency traders, are using my library as well. So let's see what is hard about doing units in C++. This is one of the software projects that I've seen on open source, and actually I contributed this to this one. This is the one, the tactical fan computer that I showed you before as a screen. It was written this style, and I actually encountered this style nearly 14 years ago, and I was scared. I tried to help in this project. Unfortunately, the owner was not that open to modern C++, so I abandoned the project at some point, frustrated. But anyway, from that point, I started to think about physical units library. I tried for many times, I failed many times, and actually, the library that I'm talking about today started with GCC 7 that was in 2017, was providing us the first compiler, concepts TS. Because C++ concepts is a great tool, and without it, it was much harder to implement such a library in an efficient way. But let's see the specific use case. We have plenty of issues here, right? You can see how many ways you can make this wrong on the call side. Then imagine that you have to refactor this, add a new parameter, reorder parameters, whatever on the list. How to update the entire code base to not make mistakes. And you think it's only open source, this project is bad? It is not. I've seen so many similar issues in the production as well. Another issue. I don't know what this code does. No one knows anymore. But it works. And we don't dare to touch it. If you touch it, if you change anything, it will just crash.
It's the scale height calculation.
I may know what are some components, like this one looks familiar, but the rest, I don't know what are those magic numbers. In order to not have magic numbers, we typically use preprocessor macros. You know those, right? Probably you've seen things like that in many places. This is the solution for the current software in many places. However, if you look closely, even in the same repo, I found those definitions in different header files. It's not that easy to use those things. Another example this is one header, and those functions are just copy-pasted one by one from this header file. In this order, they're close to each other, and try to find out what are the issues. Besides double, of course. Consider those functions that has latitude, longitude, and those functions that has longitude, latitude in the reversed order. There's also another issue here. I don't know who is seeing that, but there's another consistency issue. This one is here, distance bearing and bearing distance. So this header file is consistently inconsistent. Imagine how hard it is to user to code against such an interface. And be right, be correct. This is why I started this library. And it's not only me, I have plenty of contributors. Some of them are in the room here. So thank you very much for your contribution as well. We have also, those contributors are also doing the libraries by themselves, like Aurora units, which is great. If you're not using C++20, I highly recommend going to Aurora units library and trying it out. But if you use C++20, this may be the solution for you. What we want to achieve is, of course, compile time safety, right? We have to provide correct, by construction, code that uses physical quantities, units, and numerical values. Of course, everyone requires performance. It cannot be slower than double because no one will use it then. We are C++ developers, right? We look into assembly code. Even if you cannot measure, we want to see the same exact assembly code in the output. And talking about performance is not only about runtime, but also about space. It may be obvious to us as C++ developers that there is no space, but if you look to solutions in Java or Python, the units library provides 100 times overhead over the fundamental type for each entity you use, because of all of this polymorphic stuff and virtual functions and whatsoever that is being used there. Right? Of course, great user experience. As I said, this library is about to produce errors. The more errors a day, the better is your performance here, right? The more problems we catch. So it has to be easy to understand, easy to read, and easy to use and flexible as well. Scope is huge. People that actually try to do this as a homegrown project, they even don't realize what they started. It just comes to them after a while that it's much bigger than expected initially. Because it's not trivial, it's far from being trivial. Maybe in some narrow domain, if you want to deal with 3 quantities in an entire project, then it's fine. But if you want to do something generic, it is not, right? Because you have to account for any unit's magnitude. Huge, small, which is much bigger than the ones that you have with stud ratio. Stud ratio is not a solution here. Floating points, conversion factors as well, for example, between degrees and radians. Ratio will not support that. Besides, everyone knows about system of units, but there are also system of quantities I'm going to talk about today. Of course, affine space abstraction, right? Points and difference types that we know from Chrono and other places as well. Of course, we want to print the output. We have some different kinds of quantities. We have scalars, vectors, tensors. We have to deal with them as well. And there are some users that expect us to provide also support for so-called natural units, which are really special, if you know what I mean. But all of this is supported, or most of this right now, today, in the library, and we plan to provide this as a part of the C++ standard, hopefully. And of course, the library has to be easy to extend. As of today, the library compiles fine on major compilers like GCC and Clang. And I have a great news that last week, we were able, thanks to the huge work by our contributor, we were able to actually enable MSVC build as well. Thank you. I thank you on the behalf of our contributor, because he did an amazing job, because actually he didn't fix anything in our library. There are bugs in MSVC, and he provided plenty of workarounds for those bugs. And finding out actually what was the reason for it was really hard, because MSVC provides really bad diagnostics. So trying to find out what was wrong and fixing the code took him probably a lot of time. And this is only for the minimum support. Minimum support always requires C++20. So if you are on C++20, you are fine. Even though I'm typing C++23 here, it's an option for you. If you want to go there, you may, but C++20 will always be our target to provide this library, right? You can benefit from C++20 features like import stud or explicit this parameter, but this is opt-in. We have some compatibility, let's say, preprocessor macros, in order to support that, but we want to be backward compatible to C++20. All right? For now, MSVC works for the C++20 BER support and stud format. Enabled C++ modules opens, as Herb said during the keynote, I like this term, opens the portals to hell. Plenty of issues arise that have to be fixed as well. So hopefully it will be supported at sometime, but there are still some bugs to be fixed, mostly in MSVC code. You can find it on GitHub, Conan Compiler Explorer. So it's easy to get into, find out how it works, and you have really decent documentation as well. In case you would like to help us make MSVC work without any workarounds, please go to this URL, find free bugs there are, and please upvote them in the MSVC bug system so they get more priority and are fixed sooner. With this, we'll be able to compile our project entirely without any workarounds. Because right now we apply workarounds only for the BER library. Our examples and our unit tests do not have those workarounds. But the library, you can just get the library and use it in your projects. But then you will suffer as well as a user, because you have to provide those workarounds in your code base as well until those bugs are fixed. So let's fix them as soon as possible. As I said, this is proposed for standardization. Committee is open to and really interested actually to standardize this paper or this project. I provided a paper a few years ago that was like a discovery paper showing the design and the market solutions for that and possible plan for the future. And last year in the autumn, I came with the first paper with my co-authors. That's a huge paper that actually provides the minimum viable product for quantities and units in the standard library. So we have more papers and some associated proposals as well that are useful in order to implement the library in the standard. As I said, there's a high interest in the standardization committee. I also said many times, my ultimate goal is not to be a part of the standard. But I may do it if the committee is interested, but we have to basically dedicate our and decide what we want to do. The last thing I want to hear 5 years from now is that committee is no longer interested in this, right? I would prefer them to spend time on doing something else for those 5 years. If you don't want to do it, it's fine. We don't do it. But if you do it, then let's do it until the end and standardize the thing, right? There's no need and there's no purpose of me and many other co-authors to write those papers and go through the committee if in the end we'll hear that we don't want to do it. This happens in the history. That's why I want to make it clear that I hope it will not happen to us. All right, so let's see some taste of the Unix library. This is a code without usage of such library. And this is actually well-written code because typically it's much worse. It's well-written because you notice that in any variable, you can see the unit attached to it. And it's so important to be consistent here and during maintenance or refactoring to update those variables as you change the units here. And then we print something, it will print the correct result. So we have those postfixes that basically inform us about the units and quantities being used. And we have some conversion factors. We don't like magic numbers. That's why we typically use preprocessor, as I already shown you. It may look like an old bad code because preprocessor is bad, right? So many people what are doing instead of preprocessor, they are using consexp conversion factors. And then they are modern and happy that they are doing the correct job, right? This is what you do with this library like mine or others similar in the industry. You don't provide any units in the variable anymore because you provide them in a type. This is class type argument deduction, so you don't see actual unit in the type, but it is there, right? Thanks to CTAT, it's easy to type, easy to use, and you just initialize it with the correct value, and this will appear in the type, and compiler just hides it, so it's easy to type for you and clear. Notice that also I don't have to provide these intermediate factors here to adjust things to the conversion macros, because the library will just find out what it has to do and provide the correct answer in seconds here. And of course, the output is the same. So you have no need to track the units, and the library knows it at compile time, what has to be provided to make a conversion. If you make a mistake, if instead division will make multiplication in both cases, of course, the left-hand side will provide the answer, which is wrong, but answer will be there. In a well-behaved library, you will get a compile time error. And this compile time error is not that hard actually to read. Those are bugs in Clang. Clang likes to put plenty of braces in things. We actually make a short competition who will create a type with the most braces in the type by the compiler. But if you remove them, it actually looks quite nice. Right? We have information there's no matching function for in to change the unit, and we have information in the end that basically there's no implicit conversion between time to thing called derived quantity of length to power of 2 per time, because this is the outcome quantity type from this multiplication. All right. So this is the user code. This is the interfaces. In interfaces, it's important to not only provide the arguments, the units in the arguments of the function, but also you have to provide the unit in the function name. So you know what is the return type of this specific interface. With this library, this is what you type. And right now you can see actually the types being provided explicitly because CTAT in this case will not work. Right? So what we type here is we provide information as quantity of meters and quantity of kilometer per hour. and the result is quantity of second. All of the information is provided in a type, and this is how we spell this type. And this is so awesome because this is what C++20 gives us, and this is why the library is not available in C++17. With C++20, we got the possibility to put the class objects into the types of the template. It's called non-type parameters and TTPs, and this is one of the most important and exciting feature in the template metaprogramming in recent years. There's plenty of new use cases for that, and hopefully other libraries will also benefit from this. This syntax is as clear to read as possible. I cannot think about anything else that can be better, and it's not possible to achieve in any other programming language. Right? In Rust, Java, Python, they cannot get the same syntax as nice as we have. C++ is awesome. So now when you use it, you provide distance kilometers. I also do some conversion here and print the result. In my library, I don't have to provide the units, but actually for the next slides, I want to have two variables, so I name them differently and do the same. And of course, we have the same answer. Right? If I accidentally put a different variable to this function, of course, the left one will accept that because the compiler doesn't know that km is not compatible with m here, right, as a variable argument name, and will deliver an answer that is incorrect. Again, if you do the same with the strongly typed library, you will get the same answer as before. In this case, right, the library will find out that kilometers, those are meters, do the conversion for you, and still everything will be fine. As we are, in case you are dealing with integral types, and there will be possibility for truncation instead of scaling, you will have a compile time error saying there is possible truncation of the value, right? Because 2 meters in kilometers is just 0. You just get rid of some information, and the library will try to protect you from that. If you accidentally will replace the argument order in a call site, of course the library on the left-hand side will provide you some answer which is again incorrect. And here you get exactly a compile time error saying that you cannot convert speed from the quantity of kilometer per hour to quantity of meters. And this is what you get, this entire error. People say that concepts-based errors are not easy to read. I would say that it depends on the use case, right? There are libraries that has plenty of errors that are hard to read using concepts. I will not name them, but probably you know what I mean. But you can do it right in specific use cases. I'm not saying that I will write the other library better, but in this use case, I think that is good enough. If you make an error in the calculation inside of the function, again, you get some incorrect value. And here you get another error, saying that you cannot convert the outcome to this type. So you are safe. Your calculations in a function are checked here. Then you don't need a unit test to find out actually if the type is correct, because type system actually verifies this for you. But we need to talk about performance, or performance, as Klaus says, right? So let's find out. This is what the left column says. This is the right column. Those are exactly the same operations. They are just reversed in order because I do the scaling in a second operation here. The same performance, the same speed, even if you cannot measure that. But assembly is the same. But usage of such interfaces has one issue. If you're not having exactly the same units on your call site than are expected in the interfaces, there will be conversions. In both cases, left and right. You will have to convert to meters per second, for example, or to meters, then to seconds, and then again probably to your unit of choice at the output. Because if I want to calculate speed and I deliver kilometers per hour as an input, I'm not interested typically in a speed in meters per second, which will be the outcome of such an interface, right? I want to have kilometers per hour as an output as well. So I have to scale the values and the input and then scale the output again, which is problematic in terms of performance, and also may lose some precision during some computations. That's why we encourage people, if you want to provide generic libraries that may work with any units and unit systems, to use generic interfaces. With generic interfaces, you specify a concept. This is a concept constraint for this auto type here, cpplusplus feature, right? And you say that this is a quantity of length, quantity of speed, and as a result, we have quantity of time. You still have lots of information about this interface. Without cpplusplus, you will just have template type name, template type name, template type name, and this will be enough what you will have. You will not have information about the types at all. You could use, of course, enable ifs, but only for input, not the output. So generic interfaces are great, and with this, you will not have to provide any conversions. What you get in the input, you get on the output as a result of calculation. So let's see some cases. For example, I have some automotive application, some navigation maybe. I have distance to turn, 400 feet. So I'm using not SI, but the US customary system. Car speed is 40 miles per hour. I can find out what's time to go and say, turn right after 6.8 seconds. I may find out what is distance to Garda Lake from my home when I'm going for vacation, for sailing. And find out that my, very speed I will probably reach on highways in Germany, it will be 95 kilometers per hour. And then I can find it out, and I get the time in hours, not seconds. I may plan for the half marathon race. This is distance, is kilometers. This is my pace in average that I plan for this race. I put the same to this interface, and what happens? Who knows? Where is the error? On this slide. Minutes to seconds is fine. We know it from Chrono, so it also works. This is not a problem. Exactly, right? We have 5 lines of code, pretty readable, but we are humans. We tend to miss units, right? That's why the library has to do the work for you. This is a compile error because this is pace, not speed. Pace is an inverse of speed, right? But plenty of people having double as interface will not see this during code review. The same problem comes, for example, if you're talking about mass and weight. Weight is a force, not a mass. But people tend to do these mistakes as well. Right? Of course, if you do the inversion, everything works fine, and I know that I probably will not beat my life record in the Harvard marathon because I'm not in the best shape right now. All right, so this is the benefit of having library. 5 lines of code. Looks correct. Ship it. We also support affine space abstractions. So this time I'm using quantity points. If I see a cloud base on 1800 meters, and I'm at 1200 meters in my glider, being in a thermal, going up, at some point I have to quit because this cloud may suck me in and I will not see anything. So I find out how much time I need to spend in thermal. So I take the cloud base minus glider alt, which is then delta distance to the cloud, and provide the thermal strength as a speed in meters per second, and get information that I will spend here 144 seconds and I have to go out. Right? Plenty of different use cases, plenty of different units, the same generic interface. This is the benefit of having those in the library. So this was just a preview of what we can achieve in, let's say, bigger examples, but let's right now talk about safety features in isolation, what this library provides, and what are the rationale for it, and specific use cases. First, you've seen this already. You have quantity in one unit, and you can write in different unit, and this works fine. You can also provide implicit conversion from one unit to another, so from kilometers to meters. For integral type, it is always safe, so this works fine. But magnitudes are not at compile time, so the library will do the conversion for you, and you will get the correct result. As I said, stud ratio is not enough for such a use case. Right now, we have, I think, 4 on the top and 4 on the bottom prefixes that are not supported by stud ratio but are standardized by SI. Because std, int max or uint max can just do as much. And uint max actually is a lie. It will never be max on your hardware, even if you will have more or longer types in the future. Uint max will not change because of the ABI. We love ABI discussions. So uint max will always show you the biggest thing you have right now. So for example, 64 bits. So ratio will never be bigger and will not support those, never. And maybe for time, it's not needed to have those huge informations about the prefixes, because you are not measuring the time in those, but for sure you are measuring those in different units and quantities. Right? So there are things like electron volt, Dalton, with huge magnitudes or really small ones, and you need to account for them in the library. What happened? Oh, that's here, right? Like this one or this one. Also, as I said, there are some cases where you have to convert radians and degrees. In this case, you need pi as a conversion factor. I don't know how to make pi with stud ratio, right? So you had to find out a different solution for that. And actually, the author that provided this sits there. And thank you to Chip to finding it out and contributing from his library to mine, so we can solve this and provide to our customers. So what we do? This is how we defined kilo. Kilo is a prefix with the name k and this Mach power. Those are magnitudes saying this is just a magnitude to the power of 3 of 10. And we provide variable template to make it easier to use. Then we defined a unit called meter, and with the symbol m, saying this is a kind of length, and for time, kind of time. And you also have unit symbols in a dedicated sub-namespace that are providing short identifiers that are easy to use for the user. Unit symbols are provided in the dedicated sub-namespace, and they are opt-in only because there are plenty of them, and they may override or hijack your local variables in your project. That's why they opt-in. You can either they're using declare or user define them, and then basically take them from the using declare and using define from the namespaces and get them to your project. If you want to do something that is not prefix based, like minute and hour, it's not an SI prefix, then you provide magnitude of 60 for seconds and the same from 60 for hour and minutes, right? So this is magnitudes, not ratios in the library. And also, there are some international units that actually do not have just one integral value being a ratio. We need to provide some other ratios with mag ratio. And this is the entire interface to define the unit. Notice that each definition is just one line. If you know other libraries, probably this is not the case there. Unless this is one line of preprocessor macro that generates this much of code. With C+20, we can provide entire definition for one unit in one line, provide information about the symbol and about the conversion factor. And all of this is thanks to C+20 again. Because before you could not provide easily this text to a template parameter, and you could not make the result of this calculation easy as a template parameter. It looks obvious here, but before C+20, you were not able to do any of that. All right, let's talk about another feature, preventing truncation of data. Imagine that the data truncates and you get the speed limit on the highway. So previously I did conversion from kilometers to meters, which I say is always safe, assuming that it doesn't overflow. In case you are afraid of overflows, you have to use your custom representation type that prevents for overflows, and then you are safe. As there is none in the standard library, we cannot right now provide more safety with the standard library. The physical units library is not should not be responsible for your representation types. Whatever you choose, this is up to you, right? If someone wants to pay for checks on overflows and sacrifice potentially performance, then it's up to this person, right? If someone wants to be fast because they are not afraid of overflows, then it's another choice. We will not do this choice for you. It's the choice of representation type you use. But if you're using integral types and you do conversion in another way, so from meters to kilometers, this will obviously truncate to 0. This should not compile, and of course doesn't compile in the library, either for in or conversion constructor. Floating point representation type is considered value preserving. This is the idea and basically the strategy provided by Chrono. We are trying to be consistent here, and we have no means for now to be better. Of course, this is a lie, right? Because with floating points, we may have some issues also converting to integrals back. As long as we don't have better ways to do it, we have to deal with that. But hopefully, before the standardization, we'll get a tight trait like is value preserving, and then we'll be using that in order to improve here. But until then, we don't have this one. There is a paper proposal about it, but it's like not touched for last 3 years. Hopefully the author will come up with next revisions or someone will pick up his job. So if you're interested in this, there's already most of the work done, and you want to help, please let us know, because there's not much work to do. We just have to awake this proposal and push it into the pipeline again, possibly with some minor changes. In this case, I'm using int again as an input, but I'm converting this to double, and this also works. This one also works because double is the type provided by default by Quantities, so that's actually its conversion to double. Here we had int stated explicitly, that's why it didn't work. You can also force a truncating conversion, saying, okay, I'm working with ints, there will be conversion, but I'm fine with that. So with this, you can use force in member function or value cast to specify specific unit. For now, this is the interface we have, but we realize that force in kilometers may read wrong in case of physical units library, if you want to be exact with English language. But I assume that you noticed on this only after the fact when I pointed this out on the slide. Otherwise, it looked correct, right? But if you look deeply, it may not be the best naming for this. But we don't know the better one. IU uses coerce, but I'm not the biggest fan of this name as well. But yeah, we have some naming thing to do here. All right. So now we have floating point as an input and then converting to int. Of course, again, this is compile time error, right? Because it's truncating. You can do value cast, this time value cast. Notice that here value cast was taking a unit, and actually unit is provided as a value. Here a type is provided int for the same function, and it converts, basically forces the conversion clearly in the code. So you can see it easily during code review that something goes wrong here and possibly fix it if needed, if you'll find out the issue. But it is clearly stated in the intent of the program. So this is about conversions and about the truncation of data. So now let's see how we can use all of this to provide some interesting, maybe, scenario. Let's talk about Columbus. Probably you know about Columbus, right? He was the first one, at least in our known history, to find Bahamas and US land. He started from Tenerife, his journey, and went west. He made a lot of assumptions on his travel and plenty of errors doing those assumptions. Let's try to redo his calculations with the library. Columbus met Alfraganus. He was a medieval Persian geographer. Alfraganus estimated the degree of latitude to span for 56.67 miles. This is latitude, but well, longitude on the equator should be roughly similar as Columbus basically estimated. right? So it should be fine. So let's try to code it. This is the estimated degree by Affine. We have the ratio, and we provide the unit of mile as a template parameter. At this point in Europe, we are using Roman system. For the base of the Roman system was Roman foot, PES called otherwise. Actually, as we know it today, the official metro for the Roman foot, so the official length was the length of this statue of Kossuth. The length of this foot is the official Roman foot used in the empire a few hundred years back. Then we have Roman pace. Roman pace is the every other step of a Roman legionary going through the Europe to conquer another country. So it's 5 Roman feet. And then we have Roman mile. Total distance of the left foot, not the right one, but the left foot of the Roman legionary hitting the ground 1,000 times. Those are the official definitions of the Roman system used at this point. So let's encode this. This is the Roman foot, right? 296 millimeters. Then 5 of them is Roman pace. And then 1,000 of those is Roman mile. Did I told you that communicating units is hard? It turned out that actually Affine was not using Roman system because he was from Persia. He was using Arabic miles, which is totally different length. And when we measure this today with the known scientific calculations today and with our satellites, we know that this is the actual length that we deal with. If you provide the types for that, and then provide the error function that takes 2 quantities and calculates the error, we can find out that when converted to meters, this was the Roman mile, this is Arabic mile, and the mile error is 31%. So let's create quantities: Columbus equator length, Affine equator length, and the equator length. We are having here those 4 being printed, and fortunately to Columbus, it turned out that actually the truth is somewhere in between. Affine overestimated, Columbus underestimated. The real value is here, so the actual error is smaller, fortunately to Columbus. But he made more problems, more errors. Columbus read the Bible, specific Bible called Two Estradas. It's an apocalyptic Bible, and there is an apocalyptic book in there saying that 6 parts are habitable and the 7th is covered with water. So at this time, there was a perception that there's much more land on Earth that is actually there. That only 1/7 of Earth is covered with water. So he said that, well, then the distance they have to travel will be 68 degrees of longitude. If you know about geography, it's not true, right? It's highly underestimated. The distance from Tenerife to Bahamas is nearly 6,000 kilometers. Tenerife to Japan, 10,000 nautical miles. Notice them, especially here, providing different units, because this is how those sources are. This is how I found. And then I print more things. Columbus distance that he planned to travel was 3,000 nautical miles. Tenerife, Japan distance is more than 3 times more. This is what he planned to cover. And he actually provided all of the preparations, like food, water, for 3,000 miles. We will never hear about Columbus anymore if he was not lucky to find the land on his way. Because the land actually is nearly exactly as he calculated. That's why I know why he was so happy when he reached there. So as you can see, this code was coded by construction. You could hear my story, you could follow this easily. You didn't have to look for the problems on my slides. Because this just works. You can scope on business logic rather than searching for units error all the time in your code base. Imagine you have to write it with doubles. We'll not have that much fun there. Talk about Columbus. As I said, implementing this library is much harder than you actually may think because, well, everyone knows that there may be truncation, maybe conversion factors, because this is what that everyone knows. But there is much more issues that actually may happen, and much more features you have to cover, and you learn them on the way. So let's see some of those. This is a problem that you have with Chrono milliseconds today. Chrono is a great library. I love it. For the time it was created, it was blowing my mind at this point. It was totally changing the way I think about C++ and the libraries. But let's look at a specific case. I have a structure with vector of milliseconds, and I put mplaceback 42. It just compiles fine. The constructor for chrono duration is explicit, but mplaceback also uses mplace construction, and this is explicit. If I refactor that tomorrow to microseconds, the code still compiles fine. Finding all of the use cases in the code base where actually you put the things like that is not that easy, and compiler will not help you. This is a source of problems already on the market. This is why in good libraries, you have always to provide a unit during construction, either through our multiplication syntax or as a second parameter. You cannot just provide a number. This is not enough. Another case. We have some legacy function taking seconds, and you have to provide the value. I have vector of milliseconds here, and I have interface taking seconds. So I'm putting 42 seconds there and do count. Looks correct, right? Seconds required, seconds provided. But we forget that our type is microseconds or milliseconds tomorrow. This is not what count means here. Of course, we have wrong arrows here, and we have also duration class in the standard. But I've seen so many places where people forget about doing duration class, especially if you need much in the time of writing of the code. And then during maintenance, this may go sideways, and duration class is not put anymore to those conversions. So again, when you want to get a numeric value for a quantity in a good library, you should also be always providing a unit, which will provide you the value as needed. But let's see another case. You want to model a box, right? For example, you are in Boston Dynamics doing this robot that puts those boxes in the shelves. This is how you type it without the library. You know these interfaces, right? I've shown you those in the very beginning of the slide, of the session today, and there was plenty of laugh in the room. But this is what you do with other libraries on the market. Not mine. Those are, let's say, some libraries modeling length. How much this is better than that? I've learned that people are doing those mistakes often in their projects. And we want to basically prevent such use cases that someone provided dimensions in a different order. So dimension is not enough to actually specify all properties of a quantity. Quantity may have different kinds, frequency, modulation, right, activity, and may have quantities of the same kind, length, width, altitude, distance, radius. Those are separate concerns, separate things that we think about and should be not possible to easily convert to each other. But besides, we have different characters, scalars, vectors, tensors. Also, some of them may be defined as non-negative. We need to have some way to benefit from this information and store it somewhere. That's why we ended up with the term called quantity specification that stores all of this information at once in our library. And then it turns out that international system of quantities that is standardized by ISO 80000 specifies this tree of different quantities of length. There are plenty of them standardized as separate concerns, and there's also a hierarchy between them because width is a radius, and there's also radius of curvature for specific use cases. So this is how you model this in our library. We always can add easy new quantities. So you can add horizontal length, being a special kind of length. We can create a horizontal area, being a special kind of area that uses horizontal length and width as its calculation, as its recipe. And then we can find out that horizontal length is a length. But length is not a horizontal length because it may be something different. The same horizontal area is area, but area is not a horizontal area. Multiplying length by length is an area, but not horizontal one. But horizontal length and width is an area and a horizontal area. This just immediately works. It propagates all of the properties. You don't have to account for this. Even if you see some linear solutions based on some tag types in other libraries, they do not compose and do not propagate to derived quantities that easily as here. And that's why I'm really proud of this design, because it took me some time to figure it out. And that's why actually MP Units 2.0 was released, because it changed the way we think about this subject. So now you can implement the box like that: horizontal length, width, height, and provides those arguments properly and return horizontal area for the floor of the box. And you can initialize it as you want. You can initialize it either in an unsafe way or safe way. It's up to you. Because you may get this from some header file from some other vendor. And you may say, I don't care. This is not a concern for me. So you don't have to introduce right away all of the typed units, which is much more to type, for example. And the types are also bigger, so maybe compatible errors are a bit more harder to understand. You may say, I still want to use those simple units in my program because this is not a concern for me. But maybe a concern for someone else. Then you just use typed quantities, saying exactly what this is about, and then you get compile errors if you do it provided wrong. Compile errors like this one. And then everything is happy and works. Another answer, another problem. What is the result of adding hertz, becquerel, and baud, which are the units of frequency, activity, and modulation rate? All of them have the same dimension, t minus 1. Right? I asked boost units. I got the answer, hertz plus 1 becquerel. There's no baud, so I already checked those two. I got answer, 2 hertz. I thought that maybe always left-hand side is taken, so I changed the arguments, but I also get 2 hertz. I asked another library, really great one by the way. The answer is 2 seconds minus 1, so probably some common unit, which is actually more correct answer here. And I also asked other languages. Print from Python, they have baud. 3 hertz. When I changed the order, I got 3 becquerel. Java, don't laugh. This is how they have to do arithmetics with custom types. Provided a compile error. This is the only solution that is correct. And the compile error is awesome. We'll never be able to see such errors probably in C++. Short, it's saying exactly what is wrong. So we may laugh about the arithmetics, but compile errors there are great. To support that, we provide quantity kinds. It's defined by ISO 80000. And ISO 8000 says that quantity may be grouped together into categories of quantities that are mutually comparable. Mutually comparable quantities are called quantities of the same kind. 2 or more quantities cannot be added or subtracted unless they belong to the same category. And it says explicitly that quantities of the same kind have the same dimension, but the quantities of the same dimension are not necessarily of the same kind. And in ISO 8000, you will find plenty of quantities of dimension of time minus 1. Each of them is separate stuff. You should not mix them. For this, we provided a special modifier called kind of. It denotes the family of quantities belonging to the same kind. So basically, it says, I am the quantity of this tree. It doesn't matter which one of that, but basically, I am measured in meters, so I am length, quantity of length of this tree. You can obtain this with getKind, and then check if it's properly convertible. So when you provide those definitions, in some of them, you specify what is the kind of this for base quantities or derived units here. And with that, with this answer, you get a compile error as well. And you may say, well, hertz, becquerel, baud, those are totally different concerns. It will never happen in my project. But there are also other possible problems that we have. Most of the libraries happily on the market support such libraries as we've seen. And the code like that will work. You may have quantity of grays and provide sieverts. This is the same domain, chemistry in this case, right? One of the libraries or our units actually decided to not provide one of those. I don't remember which one, because they were afraid of those issues. This is also a solution, right? Or 1 radian plus 1 bit equals 2 steradians. That doesn't have sense, right? But this compiles on every single library on the market. So dimension is not enough to describe a quantity. We also have affine space abstractions, as you've seen, point, displacement vectors. So you can do a limited set of operations with this and prevent some obvious errors, for example, for temperatures. So there are invalid operations like adding to quantity objects, subtracting quantity points from quantity, multiplying, dividing, and more. All of those should not be possible at compile time. To summarize, MP units is about safety. You have automated but safe unit conversions. We want to prevent truncations of data. Explicit in the constructor is not explicit enough. You have to find better solutions to provide a value and a unit to a quantity to construct it. We want to get numerical values, underlying raw values in a safe way. We want to model quantities of the same dimensions, but different kinds, to be able to model different kinds of length, different kinds of voltage, different kinds of energy. If you have energy, right, kinetic and potential are different energies. You don't want to mix them in your calculations. And you have affine space abstractions. And of course, the library is not only about safety. There's plenty more of features there that are there for you to use. So please try it. Please provide feedback. Because the last thing I want to be remembered for is to standardize some crap in the library. Thank you very much.